Okay, so here I wanted to do an example from the homework of how to sketch a hyperbola. First, recognizing it as a hyperbola is important when you have both y squared and an x squared term, and we notice that there is a negative sign in between them. They're not being added together like we would see for perhaps a circle or an ellipse. So we begin by recognizing the importance of getting it into what we call standard form, which would require us to first get our y types of terms together. So here I group my y terms together. I get 64y squared. And then in my other y term here is negative 128y. And I'm going to be doing completing the square on that in a moment, but let's continue getting our x types of terms together. So we have, for example, negative 36x squared. I'm going to make some room here. So negative 36x squared. And then we have this negative 144x, negative 144x. And also when we complete the square to get standard form, remember what we do with our constants? That's right, we make sure that we put them on the other side initially. So if I move 2224 to the other side by subtraction, I would have negative 2224 on the right. Now to complete the square here, remember from your algebra days, you have to first factor out the leading coefficient of the squared terms. So if I do that here in the first place, factoring out my 64, only the coefficient, not the y that they have in common, I would now have y squared, and then I would have what? 64 times what gives me negative 128? You can do simple division here, that would be negative 2. So negative 2y there. Similarly, if I factor out the coefficient of the x squared term, that would be negative 36. Watch your signs really carefully. So that would lead us with x squared. And then again, negative 36 times what gives me 144? That would be negative, or positive rather, watch your signs here, positive 4, because a negative times a positive is a negative. So we have a positive 4x there. Now before we go to the other side, we need to pay attention to the completing the square process, which says if you have something squared plus some b times your non-squared variable, you can get the third constant term known as c by taking b, dividing it by 2, and squaring it. So taking negative 2, divided it by 2 would be negative 1, and then squaring negative 1 gives me positive 1, that's right. Now the mistake most students make is they try to add 1 to the other side right now, because what you do to one side, you do to the other side, which is true. However, by factoring out the 64, eventually that 64 gets distributed to the 1. So when we just decide to put a 1 in parentheses here, what we really end up doing is adding 64, because 64 times 1 is 64. So we have to recognize I've really added 64 here, so I'll be adding 64 on the other side. Similarly, when I do the completing the square process inside this trinomial, I take half of b, half of 4 is 2, I square it, and I get 2. Sorry, half of 4 is 2, I square it, 2 squared is actually 4, and that's the number I would normally add right here. But if I add a 4 there, what have I really done in the end? By adding a 4 in parentheses, I've taken negative 36 times that new 4, which is really negative 144. So if I've really subtracted 144 there. So if I do that to one side, I must also do it to the other side. So let's see what the net result is after this step. If you take negative 224 plus 64 minus 144, you should be getting negative 2304. So this is where we are at this point. So by completing the square correctly, we now are able to recognize what we really have in factored form as 64. What is the factorization of this trinomial? It's just y minus 1 times y minus 1, or y minus 1 squared. That's factoring. The trick is always take half of the b term. That's what we have here. Half of negative 2 is negative 1. Similarly, we have negative 36 next to x plus 2 times x plus 2, or x plus 2 squared, equaling the constant of negative 2304. Now what does this mean for us? Well, we're almost in standard form. To completely get standard form here, do you remember what we need to have on the right side? That's right, we need a 1. So normally we would divide by whatever this number is. So we divide by negative 2304 in every single term. But notice what this will do. It will give us the 1 that we were after. So we do get a 1 here. That's good news. So we end up getting something like something squared minus something squared equals 1. That's the goal, right? However, notice what happens if I divide 64 by a negative 2304. That will produce what in the denominator? That would be, yes, you're correct. It would be 36 in the denominator. So I now have a negative, however. Now this term will become negative, but what will this term become? If I take a negative divided by a negative? Positive. So it turns out the x plus 2 squared term will be positive, and the y minus 1 squared term will be negative. So couldn't I just write that as x plus 2 squared over something? What is a something? Well, if you take 36 into 2304, you should get what number? That's right, 64 minus y minus 1 squared over the result of taking 64 into 2304, which was 36. You can check my arithmetic, make sure I'm right. This looks like standard form now, doesn't it? X minus h squared, where h is the x value of your center, over a squared, the positive term has the a squared underneath it, minus y minus k squared, where k is the y value of your center, over the b squared here, which is the number underneath the negative term, equals 1. So once I'm in standard form, I can read off the type of hyperbola I have. Because the x term is positive being squared, not the y, I have a horizontal transverse axis. Meaning, in layman's terms, something like this is going on. We have a parabola opening left and right. Sorry, a hyperbola opening left and right, not up or down. We also remember that this means we're going to have a center in the middle of those two. The center here we can read off. The center is your hk. H is associated with the x value in the form x minus h. So here your center would be negative 2, comma, k, where k would be positive 1. Remember, those are counterintuitive when they're in parentheses. So in my graph here, negative 2, comma, 1, somewhere over here, is my center. Okay. Then I need to talk about my a squared, my b squared, my c squared. Remember what a gives me? A gives me my distance from my center to my vertices. So if I want to get to these vertices here and here on the major axis, which is horizontal, sorry, the transverse axis, which is horizontal, I need to find a. So let's talk about what a squared is. It looks like a squared is the 64 here. It's the denominator of the positive squared term. So a squared is 64, meaning that a is 8. And that's the distance from the center to each of my vertices on the trajectory of this hyperbola. Since it's horizontal, that would mean I'd be going left and right of the center 8 units. So let's see what that would mean here for my vertices. This would mean that I would have vertices, if I go negative 2 and I go 8 units to the left, for example, negative 2, 8 units to the left, negative 2 minus 8 is negative 10, isn't it? So I'd have one vertex at negative 10, comma 1. So negative 10, comma 1 over here. And similarly, if I went 8 units to the right of the center, you can see it here, negative 2, go to the right 8 units, where are you going to end up? That's right, 6, comma 1, because negative 2 plus 8 is 6. 6, comma 1. So those would be the two locations of my vertices, 6, comma 1. That would be my other vertex. Then I can use b squared to get b, and eventually to get c. So let's continue, remembering what each of those tell us. For b squared, for example, b squared will be the squared term underneath the negative term, the y value here. So we would say b squared is the 36 above. And in this case, that means b is the square root of 36, or just b equals 6. Now, if this was an ellipse, that would give us endpoints on the minor axis. But in this case, this is going to help us to find the slope of our asymptotes. And I know we need to find our equations of our asymptotes. So this will help us figure out, I need to go 6 units up, for example, and 8 units right. Okay? So for example, if I wanted to understand what's going on here, if I went 6 units up from the center, which is at negative 2, 1, 6 units up, 1, 2, 3, 4, 5, 6, that's 5, that's 6, that's 7. If I went 6 units up, I would need to go 8 units over, and that would be over here. So that gives me an idea of where to put that horizontal, for this horizontal transverse axis. That gives me an idea where that asymptote should go. And similarly, if I go 6 units down, so 6 units down from the center, that would be originally at 1, so 6 units below that, we would be talking about where? Would that be -5? Yeah, 6 units below, so we're at 1. 1, 2, 3, 4, 5, 6, yeah, down here. Then I would be going 8 units the other way, which would land me out at -10. So I can get that asymptote there. If you're wondering what I'm doing, I'm noticing that the slope, let me get another color here for you. The slope here is your rise over your run, right? So for these asymptotes, what I'm noticing is if I had a horizontal situation, then like I have here, because x squared is positive, then for my slope, my rise will actually be my b, won't it? So in this case, it's b over a. Now, because we did the positive, it looks like this, but technically it has a negative asymptote as well, so it's technically a plus or a minus. So it's not just going to be positive 6 over 8, but it's going to be negative 6 over 8 as well. So our slope will end up being plus or minus 6 over 8, or in other words, plus or minus 3 over 4. And you can interpret that here as well. From the center, which was -2, 1, if I did the negative version of this slope, I could have also just gone down 3 and right 4. Down 3 from 1, I'd be at -2, and right 4, I'd now be at +2 here. And I'd be able to draw the rest of that negative asymptote. I could have also gone up 3. So from the y value of 1, up 3 would be at 4. And then over 4 units to the left. And I started at -2, so I'd be at -6, somewhere around here. And I'd be able to get that sketch continuing. So as far as the equation of my asymptotes goes, these two lines, using the point slope form, y minus y1 equals m times x minus x1 is the same as y minus k equaling the positive or the negative slope times x minus h. So in this case, to get my asymptotes, the equations anyway, I simply take my k value, which was this guy here, 1, so I would have y minus 1 equaling positive or negative the slope of my asymptotes, which in this case was b over a because we had a horizontal transverse axis. 6 over 8 reduces to 3 over 4. And then x minus h would just be x minus the x value of my center. X minus -2 is really x plus 2. So as my asymptote equations, I should be having y minus 1 equals positive or negative 3/4 times x plus 2. This is the point slope version of those two lines. You could also, if you prefer, solve for y, and you could also graph the lines that way. Those will tell us, again, how wide or how narrow to make our hyperbola. But the real thing that is really behind the scenes creating the perfect hyperbola is the foci. And to get the foci, you would need c. So to get c squared, remember that for a hyperbola, c squared equals a squared plus b squared. So if you remember that's always the case for the hyperbola, then we can notice that we could add 64 plus 36, which is 100, isn't it? Which means c is just the square root of 100. In this case, it's nice and easy. It's 10. So for my foci, again, those are going to be points on the transverse axis, which is horizontal here. So from this center in the middle, -2, 1, we need to go c units left and right in order to get our foci. So if I add or subtract 10 units to the x value, h, of the center, -2, I can get my two foci points. So I would have -2 minus 10, which would be -12, 1. And I would have -2 plus 10, which would be at 8, 1. So again, I'm just adding and subtracting c from h because it was horizontal. If it had been a vertical transverse axis, I would have added and subtracted c from the center's y values instead. So you can plot those here. 8, 1 would be out here somewhere, and 12, 1 would be out there somewhere. A little bit hard to show you on my graph. Finally, I can now do a very, very basic sketch by noticing that I'm going to go through my vertices, which were at negative 10, 1, and 6, 1. So here's the 6, 1. And I'm going to be approaching my asymptotes. So that's one side. The other one was at negative 10, 1, approaching my asymptotes. Something like that's happening. Sorry, it's not as curvy as it should look. It should look more like this one. Okay. So I hope that helped. Hyperbolas do take a lot of time. You have to be really good at completing the square, watching out for tricks like factoring out the leading coefficient of your square terms, and also if you divide by a negative, being sure that you have changed the order here. And finally, recognizing that A helps you get your vertices, C helps you to get to your foci, and in order to get your asymptotes, you need to remember rise over run. Since we had to go up B units and over A units, our slope was B over A in the positive and negative directions. So we ended up with 6 over 8, positive and negative, or positive and negative 3/4. Well, I hope that helped, and if you have any questions, feel free to reach out to me, and remember to practice, because math is not a spectator sport. I'll see you next time.